Hi, welcome to an Arduino step-by-step course by Robojax. In this tutorial, I'm going to show you how we can use this L298N motor controller module to control two DC motors with push buttons and potentiometer. So you will press a button and motor 1 will rotate or stop or go counterclockwise, or you can control the speed of it, or you can go with the motor 2, stop and control the speed. You can control larger motors as well. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I've written a library for this module so you can use the motor controller easily. I have a separate video explaining that. Make sure to watch it and make sure to just control the motor with Arduino IDE without any push button or potentiometer. After that, come to this video. If you do not watch that video, you will have a lot of issues and questions and your time will be wasted a lot. There are times that you need to stop and start the motor, and you should be able to change the direction of rotation, and also should be able to change the speed of the motor. So I'm going to demonstrate first one motor, wiring, code and demonstration, and then I will go with the two motors, wiring and demonstration. So it will and I will provide you two separate code so you can use it either for one motor or two motors. If you want to control a motor that draws, let's say 2 or 2.5 ampere maximum, you can replace the heatsink with a larger heatsink. So you can connect two motors that each can draw 2.5 ampere. Let me now explain the wiring. The wiring diagram for L298N module with controlling one DC motor with push buttons and potentiometer. This is our battery, which can be between 6 to 35 volts. The positive of the battery is connected to this point, which is incorrectly labeled 12 volts. The ground is connected to the ground. From this ground, we have a wire connected to ground of Arduino, which can be connected on this ground or any of those. And then this is 5 volts out from this module. This is connected to this point. This line is now 5 volts, which we have a red wire connected to this 5 volts. You have to understand that this wire will be removed when you connect USB. Keep that in mind. And then for potentiometer, and from this ground we have a wire here to this point, so this line is ground and this is 5 volts. The potentiometer's wire, the left wire, is connected to the ground. The right side is connected to 5 volts. And the middle pin, very important, the middle pin cannot be connected to 5 or ground. From this point, from the middle, it has been connected to analog 0, which we will control the speed of motor. We have 3 push buttons here. The right or left doesn't matter. In this case, I'm using right pin of this, right pin of the second one, and right pin of third one. They all connected to the ground. And then the left pin, the first one, the CW, is connected to pin 8. And the second one is connected to pin 9, and the third one is connected to pin 10. The motor 1 is connected on this side where you put the heatsink and these wires. It will be connected here. The 3 pins that we have, enable pin, which needs pulse width modulation, have been connected to pin 3, and then N1 is connected to pin 2, and N2 is connected to pin 4. This terminal is for motor 1, and my motor is connected to this terminal. Here we have 3 terminals. This is connected to your battery. The battery is your voltage for your motor. If motor is 12 volts, connect here 12 volts. If motor is 24, connect 24 volts. If it's 30, connect 30 volts. doesn't matter. So the positive here, the negative is here. These two terminals, these two wires go to your battery, and the middle one is ground. From ground, I have one wire connected to Arduino here. This last wire will provide 5 volts. When you connect, let's say 12, anything above 6 volts, 6, 7, 8, up to 35 volts can be connected here. It goes and converts to 5 volts, and this line on the last one supplies 5 volts to Arduino. When you disconnect it, it will supply the Arduino. But when you are programming it, make sure to disconnect that wire, because we don't want another wire, another 5 volts here, because that 5 volts and this 5 volts might be a little different and the current will flow in between. So disconnect it when you're programming it. This is enable A, that's pulse width modulation pin, in 1, in 2, and then we have in 3, 4, and enable B. Enable A is for input 1 and 2 for one motor. Enable A is connected using this purple wire to pin 3, and N1 is connected to pin 2, so this goes to pin 2, the gray, and N2 white is connected to pin 4. Make sure that this pin, the first pin, must be pulse width modulation pin, and this tilde here, it says that this is pulse width modulation. 4 is not, then 5 is, 6 is, 7 is not, 8 is not, and 9 is. Those tilde means pulse width modulation pin. I'm using these type of push buttons for breadboard, but if you're not using breadboard, you can use the other ordinary push buttons, because these are long and I bought them from eBay, easy to use, and I've inserted them here in breadboard. The left side is one pin, and then middle is empty, and then the next pin. All of the left side of this is connected to this point. The second push button is also from here, it's connected to this point, and the left pin of this. So all three will be connected to this, which I will connect from here to ground. Here 4 wires. The first wire will go to this pin, and then the second wire goes to the second pin. The third wire will go to the third one, and then the fourth one is connecting in this line. These are all connected together up to here. So this is my ground. The yellow will be connected to ground of Arduino. Here I have a ground here, I'm connecting it ground. And these 3 will be connected to pin 8, 9, and 10. And in here. This goes to 8, 9, and 10 accordingly in here. Now for potentiometer, which has 3 wires, one of this side and one of this side will go to 5 and 0. Now, because when you go to the right, you want maximum, so this pin is better to be connected to 5 volts. And for potentiometer, we can use from 5 volts, bring a wire from 5 volts and bring it to an empty spot on your breadboard. Now, this is all 5 volts. So I can connect my potentiometer like this. We'll connect it to 5 volts. This is my 5 volts. And then the left pin on this side, this will be connected to the ground. And also remember, this is all also ground here. And then the middle pin must be connected to analog 0. Not this middle pin cannot be connected to 5 volts or 0, otherwise you'll create short circuit when you rotate it to the left or right. So this must be connected to analog 0, and now it's ready. When you now program it, disconnect this 5 volts, but once the programming is done, you can disconnect this and connect this 5 volts. Now, because this pin is occupied, and this is my 5 volts, I can connect it to this 5 volts here. Now Arduino is also powered from this 5 volts. Now let me explain the code. First, you have to download and install the library, as I've explained before. You should have already done it. So we are going directly to the explanation of code. This is the Robojax L298 DC motor library. We are defining pin 2 and pin 4 for N1 and N2, and pin 3 for enable. This is pulse width modulation enabled pin. And if you're using second motor, pin 6, 7 and 5. 5 is also pulse modulation pin enabled. And then we are defining here CW and CCW. Do not change it. And also we are defining motor 1, motor 2. So throughout the code you will not use 1 and 2 to refer to CW, CCW. So this will make it easy. And also we will be using motor 1, motor 2. This way this will be understood easily. This line below, it says potentiometer and push button 1 and push button for motor 1 started. So this is a starting point. We are defining a constant of integer, a variable called motor 1 push button CW, and then the rest is exactly the same. At the end it says stop and then CCW. So 3 pin is defined, 8, 9, 10 for push button of motor 1 for this CW, CCW and stop. And we are defining pot 1 input or potentiometer 1 input as analog 0. You can change them accordingly if you need to. And then here we are setting motor 1 minimum, because many DC motors will not start running with a minimum pulse modulation value. So this is in terms of percent. When the program runs here, and if I press a push button, you will see that this is 71%. And with potentiometer, you can rotate it left and right and see at what value your motor starts rotating. So you can just go a little below that. So we set that value, and below this, do not change them. Direction of motor 1, this is internally remembered. Stop state, motor 1 speed. So this will be updated with the code below. And if we want another motor, I will show you that we will copy and paste this one more time and set the values for the second motor. And this line is to initialize create an instance of this class. We call it motor, and then N1, N2, N3. These are the pins for module for the motor controller L298N, and enable and true. If you want to see this debugging information like this, then set this equal true. Otherwise, as I've explained it, and I ask you to watch the video, the basic video of this motor, the basic introduction video, remove this like that. It will not print the debugging information. Inside the setup, we initialize the serial monitor with 115,200. That is the value that we see in here. If I open this on the right side, it must match with this, otherwise it will not display. For example, if you go for something else, the value will be displayed like that. And then motor.begin initializes the motor value, and inputs other parameters will be set. And then we are defining 3 pins here using pin mode as input with pull-up, input pull-up. I have separate video explaining that. And here I can tell you that we are eliminating using of extra resistor by using input pull-up for CW, CW and stop for 3 of them. Inside the loop, we update the state, which is a separate function. I will explain it next. Then using analog read, pot 1 input from input analog 0, we read the value and store it in the integer type variable called pot value. And then using the map, we get the pot value, which is from 0 to 1023. This is the beginning, this is the end, and it will map it for us to the potentiometer minimum value, which we set above 0 or 15 or 20% to 100. So if this is 0, the percent value will be whatever is set here. If it is 1023, it will be 100%, and the value and the calculated value will be stored here as motor 1 speed. And we check here if motor 1 stop state is equal high, which means if there is stop requested or applied, then motor 1 brake. So this will apply brake to the motor, will stop. If it is not high, which means else, then we use this command to control the motor. We say motor.rotate, and then which motor? Motor 1, and then motor speed, which has been calculated here from potentiometer, and then motor direction, which has been defined with a push button, which I will explain next. And then we have 100 millisecond delay. These are just extra for test, and it will continuously, and the loop will continuously do the same task. Update state is reading the push buttons, which have been set here. We check if digital, using digital read, motor 1 push button CW, this is the pin. We check if it is pressed, the value will be equal low. This 2 equal sign means compare this with low if it is true, and these 2 ampersand mean and. Motor 1 stop state is not equal to, this means not equal to low, which means it has not been set to run. Then because high means stop, low means run, then we motor 1 direction, we set it to CW, and then we set the brake to low, which means do not apply brake. And then we do the same thing for CCW. This time we set the direction for CCW and also set the motor state, stop state, and this line will read the push button with a stop. If it is pushed, then we set the motor stop state to high. So these variables have been defined at the top of the code. That's why I said do not change them. And we constantly update, read the push button every 100 milliseconds inside this loop. The loop will go and first read, and then will apply the proper CW or CCW to the motor. Want to connect 2 motors. The connection for the first motor is exactly the same. I've added extra potentiometer, 3 extra buttons for the second motor, for motor 2 and the motor 2. And in this case, the same as the first motor, all the right side are connected to the ground, and the left one is, the first one is connected to pin 11, the second one is connected to 12, the third one is connected to 13. For the second potentiometer, the same way, the left pin of the potentiometer is connected to the ground, which I mentioned, this line is ground, and the right pin is, this pin is connected to 5 volts, and the middle pin is connected to analog 1. The first one was analog 0, this is analog 1. And for the second motor signal that comes to this module, input 3 is connected to pin 6, input 4 is connected to pin 7, and then enable B, which needs pulse width modulation, have been connected to pin 5. And here is for the second motor, I've connected these 3 wires, blue, green, yellow. The yellow is connected to enable B, blue is connected to pin 6, green is connected to pin 7 at this point, and yellow, the last pin, is connected to pin 5, which is pulse width modulation for the speed. That's very important. Here I've prepared these 3 push buttons now for the second motor. The same as before, the left pin of each push button is connected to this point. This middle push button, the left, is connected to this point, and the left pin for the third push button is connected to here. From here I've connected them all to the ground, which is connected to ground via this yellow wire to Arduino. And here I've connected now 3 wires at this point. The middle pin is not connected, that's ground, and this side is a signal for this. And these 3 wires have been connected here, being connected to 11, 12 and 13. And here is the second potentiometer. I will connect the right side of this to the 5 volts that I've created on this breadboard. This is the breadboard, the 5 volts that I have. And the left side I will connect it to the ground. My ground is here and the middle one will be connected to analog 1, not analog 0 at this point. Let's copy this up to here, and I will paste it and update it. And here I've changed every 1 to 2. Here all the motor 1 have been changed to motor 2, and I've defined values 11, 12, 13 for these push buttons, and analog 0 has been changed to analog 1, and here the same way all the motor 1 has been changed to motor 2, including this. I've commented that line and removed the comment that was here, so now this line will take the N1, N2 and enable A, N2, N3 and N4 for enable B. True means we need comments. Once you complete your development, remove this so it doesn't waste the resources. Here I've copied this in here and I changed all the 1 to 2. So I'm going to copy this and paste it for motor 2. And here update state have been changed to 2, pot have been changed to input, value, minimum, speed, and then this, and then including this, motor 2, speed 2 and direction 2. So I've just copied and pasted. Now it works for motor 2. This is a demonstration of a single motor use. I'm going to open the serial monitor now. As you can see, it says motor 1 braked. Currently the motor is stopped. When you start it, this is how you read, and I've set this at the minimum for this motor because the motors can start at different level of percent. Minimum I set it for 20%, so 20% will make this not to run. Let me go, for example, right now clockwise, it's running. If I go for minimum, that's the minimum, so you cannot go below this, and we can change it to different value. For example, if you want to go for 10%, you can set that for 10% and it will be 10, or if you want to set it 0. I provided this option because in many applications people will need it definitely, because this potentiometer will the motor will not respond with different percent value. So now it's uploaded at 0. Starting the motor, you see it makes buzz because the amount of power is not enough. Now at this value it rotates. Perhaps, let me open the serial monitor, 18%. So if we set that to 15 or 18%, that this will run very smoothly. Let's set it to 15, a proper value so we know. Thank you for watching. This was how to control 2 DC motors using L298N motor controller. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. Thank you for watching the tutorial from Robojax. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, please post it at the comment section below. I try to answer and reply. And don't forget to subscribe so you get updates of my upcoming videos.